Our protocol describes how to assemble and electrically characterize a peptide-doped biomembrane that closely mimics the composition, structure, and transport properties of biological synapses, and which exhibits tunable memory resistance. This technique empowers users to assess activity-dependent memory resistance and short-term plasticity in engineered systems at timescales and excitation levels relevant to biological synapses and ion channels. This technique provides a framework for characterizing biomimetic membranes containing voltage-activated ion channels, making it applicable to the characterization of a variety of cellular transport processes, including those in neurons. Our suggestion to new researchers is to first become proficient at preparing liposome solutions and assembling a droplet interface bilayer on wire-type electrodes. Seeing firsthand the process for droplet dispensing and positioning on electrodes simplifies this technique for bilayer formation, making it immediately accessible to all. Demonstrating this procedure will be Dr. Joseph Najem, a postdoc from my laboratory.
To begin, prepare the alomethicin stock solution in the microcentrifuge tube by dissolving the alomethicin peptides powder in ethanol to a final concentration of 2.5 mg per milliliter. Vortex the tube briefly to mix well, and store the stock solution in a -20°C freezer. In a 1.5 milliliter SafeLock tube, add 1 microliter of alomethicin stock solution to 99 microliters of solution A to achieve a final alomethicin concentration of 13 micromolar in the liposome suspension. Vortex to mix well. The resulting peptide liposome solution is solution B. Mix 117 microliters of solution.